So the first step we will do before understanding or going further, we should know what is regression. So regression is basically done to establish the relationship between the dependent variable and the independent variable. So there could be univariate regression or there could be multivariate regression. Univariate regression is where you have a single independent variable and you are testing the change of the independent variables and their impact or change in the dependent variable. Multivariate would be basically where you have number of variables together. So the main objective of doing it is you can forecast the future values of the dependent variables by looking at the change in the independent variables. So I will first start by putting the data. So we will use Yahoo Finance. You can go to Yahoo Finance and let's look at Nifty first. Nifty is, you know what is Nifty, right? Yeah. It's Nifty 50. So what I do is I take last 5 years ka data, daily prices. Okay. Last 5 years data and daily prices. I'll just share my screen so that you'll be able to see it. Now, yeah. So last 5 years data, we take the daily prices. Nifty Yahoo Finance में जाके search Nifty 50. Go to historical data, 5-year prices daily, and then यहाँ पे you will see a download button. You will see a download button there. Download it. The moment you download, a CSV file will open up. CSV stands for comma separated values. Now, do not use this file because if you use this file, then it has a lot of inhibitions and restrictions. You may not be able to do everything successfully. So copy the data. Copy the data and put it in your Excel file. So I'll put it in my Excel file here. Okay. Now I don't need all the data. I just need the date and the adjusted close. I don't need anything else. Okay. And I don't need decimals. So you can remove the decimals. Okay. Now, please remember that when you're working on data, when you're working on any such analytics, you should always work on relative values, never absolute values. So we will convert our prices to returns. We will not work on prices. We'll convert them into returns. So returns, how you'll do it? Simple. Just take the next day price minus the previous day price divided by the previous day price and convert it into percentage. Okay? Just look at the formula. Next day price minus the previous day price divided by the previous day price, converted into percentage. And now you don't need to do it again. Just double click on the dot. All your Nifty returns will get calculated. Clear? Next, what we do, we repeat the exercise, but this time with, let's say I take Infosys, and I go to Infosys here, and I go to historical data. Okay. And then I choose the 5 years option because I want 5 years ka data daily. All right. And then I download the data. Again, when you download, you will get a CSV file, a comma separated values. Now, don't need to again copy. Yahan pe copy karo and put it in your Excel file here. And do the same thing. Remove all the other columns. Just let your adjusted close be. That's it. You don't need anything else apart from the date, of course. And remove the decimals because we don't need to work on decimals. It's huge data. So even rounded off values should work. Clear? अब हमें क्या करना है? हमें चेक करना है कि कोई पहले तो आप रिटर्न्स करो, कुछ करने की जरूरत नहीं है. Copy this here and paste it here. Automatically the formula also gets copied. So once you have the returns for Nifty and for Infi, the next thing is to do a sanity check. Sanity check basically means that there should be no null values in the data. For example, अगर मैं यहाँ पे sanity check करता हूँ returns पे, मुझे कहीं पे भी ये नहीं आना चाहिए. I shouldn't get any null values. यहाँ देखो, अगर if you are getting any null values, you should be able to remove it. तो यहाँ पे कोई, हाँ देखो इधर भी है null. Can you see that here? There is a null value here. There are two null values on 27th October 19 and 14th November 20. So we will need to remove these null values. So how we will do it? Simple. Just Control F karo and type null. Control F is for find. Type null. तो आपको वो null की जगह पे ले जाएगा. And now just take the previous day price, because कई बार क्या होता है, this data, it doesn't get populated. It may be the next working day and this is not got populated. So just delete it and take the previous day price. तो null अपने आप हट जाएगा. Again, Control F and press null. Again, you will be here. There were two null values. So यहाँ पे is equal to previous day price. Now you have cleaned the Nifty data. There is no null value there. Same way we will look at Infosys and see if there is any null value. There are no null values in Infosys. So Infosys ka data is clean. Now we have done the sanity check. Next step is now to do the regression, because we already have the Nifty and Infi data. We just will give headers so that when you are referring to this file later, you know which stands for what. Now, please remember, when you are doing a relationship between Nifty and Infi, Nifty is always on the x-axis because that is the independent variable. And stock, in this case Infi, will be on the y-axis because you want to measure how the stock behaves in relation to changes in the marketplace. Okay, so that becomes on that is on the y-axis. Now go to the data tab, and once you go to the data tab, you can simply go to data analysis. तो वो आपको बहुत सारे analysis देगा, regression, sampling, testing, all that. So we take the regression and press OK. Now it will ask you for Y range and X range. है ना? So it's very simple. Y range, we are going to choose what? Infi. This data here. This becomes your Y range. And X range pe we are going to use Nifty, which is this data here. Once you plot your Y and X ranges, you can put the output here somewhere at the beginning of the sheet so that it's easier to access, and press OK. जैसे ही आप इसको OK press करोगे, your output sheet, which is your ANOVA sheet, will get created. This is your ANOVA table analysis of variances. Now we will try to validate these numbers. First, always I change it to 7 decimals because these could be small numbers, so it's easy to work on and it becomes standardized. Okay. The first thing that you look here is multiple R. What is multiple R? Multiple R represents the correlation. It is the correlation between Infi and Nifty in this case. So this represents correlation. And please remember, a correlation number could be positive or it could be negative. Generally, correlation lies between +1 and -1, where +1 is perfectly positively correlated data sets and -1 represents perfectly negatively correlated data sets. Now you can also validate this correlation here. It is 0.57170. So I can use the Corel function. Is equal to Corel. It will ask me for the two arrays. So the two arrays are nothing but your Nifty returns and your Infi returns. And press here, you will get your correlation figure. You will see the same number here, 0.57170, 0.57170. Okay. Similarly, we can also validate the intercept by using the intercept function is equal to intercept known y's and known x's. Now, please remember, known y's will be your Infi returns, stock returns. Known x's will be your Nifty returns, market returns. Now, you should get the same number. ये देखो, exactly same. 5 decimals पे लेके जाओगे तो 0.00032, which is the same thing as the intercept you have got on the ANOVA table. The next one, x variable 1, is basically your slope, dy dx. Okay, that's the slope. So you can validate that using the slope function is equal to slope known y's and known x's. So your known y's is Infi and known x's is Nifty. And you will see that the number should exactly match here. 0.85563, 0.85563. So that is the slope. So now what is the slope represent for markets? What is the slope? It represents the stock beta. So ये जो number है यहाँ पे, ये Infosys का beta है. That means it's a sensitivity index. It measures how Infosys responds to a change or anticipated or unanticipated events in the marketplace. That's what is beta. So it's measure the sensitivity of the stock, in this case Infosys stock, to the market, in this case Nifty index. So that can be obviously because slope aapko pata hai, it's dy dx. So it is a change in y caused by a change in x, or a change in Nifty caused by a change in, a change in Infi caused by a change in Nifty. The other thing that we should do now is we should validate these two numbers, regression sum of squares and residual sum of squares. But before that, I will plot this on a scatter diagram. तो मैं एक scatter बनाऊंगा for the Nifty returns. I can take the recommended scatter here. And इस chart को अगर आपको, if you want to really see it properly, you can probably just drag it a little so that it gets kind of spaced out. यहाँ से भी. So now you can see the scatter properly. So this is your scatter diagram. Now what we will do is we will add. Now this is only Nifty as of now. So select data. ये actually गलत जगह पे आया है. This should be X values should be Nifty, right? So your X values will be Nifty. So I take the Nifty values here and I put it in the X axis. Y के लिए I will choose the Infosys data. यहाँ से. And I'll put it in the y-axis and I will write here Infi versus Nifty. And press OK. Now you will see a proper chart coming in. Now look here. This is a proper central tendency chart. यहाँ देखो आपको दिखेगा maximum are around the center and there are some outliers also. You can even add a trend line. You want, you can change your colors, like इस type का भी कर सकते हो आप. And whatever you like, basically. There are a lot of options it gives you. And then you can add a trend line. So I will add the trend line here. A linear trend line. तो ये देखो आपको trend line भी दिखेगी बीच से. Can you see the trend line now? So that's the trend line of best fit भी बोलते हैं इसको. I'll click on the trend line and I will format the trend line and I can display the equation on the chart. तो वो equation भी आ जाएगा इधर. ये देखो. Y is equal to 0.8556x plus 0.00003. Now, if you go to the ANOVA table on top, you will see the same equation here. Y is equal to 0.8556x plus 0.00003. Now we can validate the regression sum of squares and the sum of squared errors also. See, the idea of regression is what? The idea of regression is to find out the establish the relationship between the dependent and the independent variable. तो हमें ये देखना है to what extent is the regression plot able to establish this relationship. So there are two types of variances which can occur. One is your explained variance, that is something which is explained by the regression model, and the unexplained variance, which is not explained by the regression model. So sum of squares करते हैं. So if I take the explained variance, it is nothing but the predicted values minus the mean value squared. Predicted by the model minus mean value squared. So we will first plot the predicted values. So this is y, right? So हमें yp minus y bar करना है, where y bar is the mean. So I will take the mean value here, average of the infi returns. Okay, this is your average. Now yp, predicted values is what? Predicted values is yp minus y bar whole square. So पहले हमें yp चाहिए. Predicted values is y is equal to mx plus c. So m हम यहाँ से लेंगे intercept into x. X is your nifty return plus, sorry, m is your, sorry, y is equal to mx plus c, my mistake. M is your slope. So m is here into x, which is the nifty return for that observation, plus c, which is your intercept. And then convert it into percentage. Now m and c are constants, so I will freeze m and c, static referencing if you remember, and then double click. तो मेरी सारी predicted values आ जाएंगी यहाँ पे. And now you can find out your regression sum of squares, which is yp minus y bar whole square. So predicted values minus the mean of the Infosys returns whole square. And always take it to 5 decimals. And mean को भी हमें freeze करना है, because वो static reference है, और इसको नीचे drag करना है. Now if I take a sum, this value should be equal to the value that we just saw. ये वाला. Look here. 1, 3, 3, 4, 5. Can you see that? This is the regression sum of squares or the explained variance. 0.13345. ये देखो इधर. 0.13345. Same way for your unexplained variance, it is actual minus predicted squares or sum of squared errors. So actual value of infi minus predicted value of infi, right? Return actual minus predicted whole square. Sorry, whole square. Okay. Again, convert it to 5 decimals. Double click and take a summation. 0.27485. यहाँ पे 0.27485. Now if you look here, this is your रेसिडुअल सम ऑफ स्क्वायर्स और अनएक्सप्लेन्ड वेरिएंस 0.27485, यहाँ पे जाके देखोगे तो आपको 0.27485 दिखेगा। दिखा? दैट इज योर अनएक्सप्लेन्ड वेरिएंस और सम ऑफ स्क्वायर एरर्स। इसको रेसिडुअल टर्म्स भी बोलते हैं। नाउ इफ यू लुक एट दिस पार्ट हियर, दिस इज द लास्ट पार्ट. How much, to what extent, if I want to find out to what extent our model is able to explain the relationship, I can take the explained variance as a proportion to the total variance. कितना आता है? 0.32684, right? Regression by total कितना आया? 0.32684. Is it matching this number here? R square. R square is the coefficient of determination, and it shows you to what extent the model is able to establish the relationship between the independent and the dependent variables. So that is R square, and you know that how I have found out R square. It is RSS by TSS. Regression sum of squares divided by total sum of squares. So this was a little bit around regression and understanding and drawing inferences from the ANOVA table.